I don't know where I got the idea that there was 50 questions in one of these sections. It's only got 29. I have no idea where that thought process came from. So let's jump right in. We are looking at essentially how do you differentiate using the shortcut, which is for us the power rule, on various functions. And we've done a fair chunk of the ones you'd likely see. I just don't want to do a few more practice. That's these guys here. After I've done that, we're going to look at how to find the equation of a tangent line and how to find the equation of what's called a normal line, which is something new. And then hopefully for the last, whatever it ends up being, 10 minutes or so, I want to talk about test one and get us all ready for that. So let's jump right into it. And this one is not meant to be tricky. Sometimes you have to know when you don't need to do stuff to something. Would you agree you don't need to do anything to this ugly function? I can use its power rule. And so you multiply by the power and you reduce the power by 1, and you multiply by the power and you reduce the power by 1. And again, you have to know when you don't need to do stuff. As far as style points go, is it not an acceptable answer? Doesn't it look like the original? It's got ugly negative and halves and things, and I'm cool with that, and you're finished. So, next one is a bit like question 9. S of t, 1 over t, plus 1 over t6. Do you recognize that that question does need to be fixed, right? You have to write it in a new way so that we can do the power rule on it. So essentially, to use the power rule, things have to be written as powers. Pretty obvious thing to say. This guy is t to the negative 1, and this guy is t to the negative 6. Agreed? 1 over t is t to the negative 1. 1 over t to the 6 is t to the negative 6. It's using the rule in algebra that says fractions can be turned into negative powers, as they are here. Now you can differentiate. And you multiply by the power. And then reduce the power by 1. And you multiply by the power. And you reduce the power by 1. And like in this first question, you have to know when you don't need to do things. You also do have to do things sometimes as well. Would you agree that this answer is not algebraically considered the best form? Because the rule that we're using essentially right now is that it has to look like the original. And this guy does not look like the original, right? So this fella is going to become negative 1 over t squared. And this fella is going to be negative 6 over t to the 7. And now we're finished. So that's the answer. We're good? Power rule. Multiply by the power, reduce it by 1. So what have I picked? 12 for, I should say. Okay, I need to differentiate this function. Would you agree I need to do something to it before I can differentiate? So we have to figure out, you know, in this case here, I had to convert them to negative powers. And what do you think I need to do in this case to get it ready to be differentiated?
You need to distribute it.
Okay, so you get x to the 4, and you get 4x cubed. And then you differentiate it. Power rule can be used now. That's fine. I mean, yeah, that's fine. The reason I was kind of semi-hesitating is that this is acceptable. I would have no problems with you doing that. But if I was in a, I guess, tidy up mode, couldn't I factor it as well? But I'm not pushing that. I mean, right now, I'm not pushing that. Later on I will, but not now. So if you get to there, you're fine. And I'm pretty sure WebAssign will accept that. So that's all you really need to worry about right now anyway. Okay. Are we feeling a little bit more comfortable the more examples of these guys you do, how to deal with situations that don't just require you to use the power rule? So here's another one, a little weirder, but not totally new, I hope. Would you agree that guy is definitely not ready to be differentiated? That guy is ugly. And we need to figure out some way of rewriting it as powers of X so that we can do the chain rule, do the power rule on it. Any suggestions about how we can go about that, what we can do?
Make it 3x to the -2 or negative squared, or
I like half of what you said a lot. It's a very common mistake, and I'm kind of happy. Yes. Now you may say, well, what about that 3? That 3 is there. The problem is that 3 is really still on the bottom. So there are a couple of ways of looking at this guy. None of them are very pretty. If we just pretend the 3 wasn't there for a minute, what you're going to do is convert that guy into a half power, leave that as 9x, and just like you said, the -2 bit, right? That 3 doesn't go there. That 3 is a totally independent of itself. In fact, that 3 is in fact a third. So it's not 3x to -2, it's a third x to -2. But it's a very common mistake. You see, algebraically, it might seem sensible that that's what you should write, but in reality, it is a third. I mean, if I drew a big line and just wrote the 3 in the bottom, you might see it a little bit more. Now, so I've got a third and that. I've kind of separated them in a way to try and emphasize that. So if you multiply this and this together, you get 5/3. A half and a -2 ends up getting you -3/2. A third times that gets you 3. And x in that one, when you put them together, gets -1. And that, when you multiply it all out, becomes this. Not very pretty. Check it again. 1/3 times 5 is 5/3. And x to the half with this guy gives you -3/2. A third times this gets you 3. And x times that guy, -1. I can now differentiate. Multiply by the power, which is -3/2, you get -5/2. Reduce it by 1, you get that guy, -3x to the -2. Right. Multiply by the power, reduce it by 1. Multiply by the power, reduce it by 1. If you're wondering what happened to the 3, you get cancelled out with that 3, and the 2 still survives. So that's why it's -5/2. And then to make it pretty, at least it's a fraction. Do you think 5/2 is a good format based on what the original looked like? Can I leave that as 2x to the 5/2, or should I fix it? Okay, then if I have to fix it, because I've seen some shaking of heads, how do you fix 5/2? What do you write it as?
The square root of x to the 5th.
Right. Now, not even on a good day would I consider that a nice question, right? It's ugly, it's messy, it's got fractions in places you don't want fractions. It's just generally horrible. Thankfully, most questions aren't that bad, but you know, you have to be able to deal with everything, and that's one of the everythings. Okay, so I chose that one because it was so ugly and messy. In fact, all the ones that have to come have got something ugly or messy or weird about them. And there's one more that I forgot that I'll put in at the end. So this is a version of question 16. Now, I want these guys to be ready for the power rule. This guy here is going to be the square root of 7 t to the -1. I don't think that's too weird, right? You could, okay, square root of 7 is maybe not nice, but if it was 4/t, wouldn't it be 4t to the -1? The number, even if it's a square root, doesn't matter. This guy here is much uglier. It's the square root of 2t. Not the square root of 2 times a t, but the square root of 2t. And you notice what I've done is I've split it into two things, square root of t and the square root of 2, right? Which means that I need one extra line. That's the algebra finished. The original expression, which we can't use the power rule, has been converted into 2 powers of t, these two. I can now differentiate. Multiply by the power and reduce the power by 1. Multiply by the power and reduce the power by 1. That is the calculus line finished. Everything I'm about to do from this point onwards is style points. I am going to rewrite this thing so that it looks much more like the original. Okay. A -1/2 power can be written as a positive power on the bottom. A negative power can be written as a positive power on the bottom. Okay, so it's beginning to look a lot like this. This here looks very good. I'll leave that. I think I'm done. What do you think I'm going to convert the square root of t? Oh, I just said the answer there. When I convert this t to the half into the square root of t. Okay, so there isn't a question now. And that looks really good. And if you got that far, I'd actually be really happy. But it is possible to make that a little bit nicer. So if you could do this next bit, that would be really good. Can you think of another way of writing? I'll do it in nice big letters. This guy.
Square root of
Just
2 over 2 square root t.
square root of 2 over 2 square root of t. I think that's what I heard. Agreed? I agree with you. That is better. Can we do even a little bit more? Just one more, tiny little bit more. And by the way, I'm quite happy with that as an answer. Let's just be nitpicky. Can you make this here slightly prettier?
Multiply top and
Or
bottom.
at least,
square root of t.
now, there is a lot of arguments, I'm sure you could have with all sorts of different people, between which three flavors of the answer you would consider to be the prettiest, right? And if this was a beauty contest for equations, I'd probably vote for the middle one. But some people might think that this is better since you've combined the square roots.
Can you make it any
not as many,
bigger
but
or
some
not?
of you might like. Say again?
Yeah, can you make it any bigger? Like, can you zoom in a little bit? For some reason, I'm having trouble seeing stuff.
Well, I tell you what I can do.
I guess it's my old
I'll
eyes.
just write it big.
Okay.
Oh, tell me about it. If I was a horse, they would have shot me by now. Right.
All right. Thanks.
That was like the ultimate version of what this guy would look like.
Okay.
Should I be writing? I mean, this is true about the screens that you're using. I forget I'm using a blinking huge big screen, so everything looks very big to me, but that's because my eyesight's so bad. But I probably should write bigger just in general.
It's my fault. I'm on.
Okay,
screen, so I'll change it to gallery. Sorry. Yeah.
No problem. Right, 19. This is this would have been the last one until I remembered I forgot one. The kind of ultimate version of horrible. We have to figure out how to rewrite this so that we can differentiate it. I mean, you don't need to tell me in one go. It'd be nice if you could, but could you tell me just anything we could do to at least get us on the road to fixing this? And we have some really messy things going on here.
Conjugate, or would you start with the V and get rid of it?
I get rid of the V.
Okay.
Conjugate techniques really not going to be used in differentiation. It's used in limits a lot, and it's not that helpful with derivatives. Because if you try and use the conjugate method on a derivative, you make the top prettier, but you make the bottom uglier, so you're no better off. Right, so that's why we typically wouldn't use it. But the V was a good start. Are you going to call it? Oops, there's a V here. Are you going to call it V to the negative 1? You're going to go that way? Is that what you're thinking? V in the bottom? Yeah, okay. Could I do something about that cube root? Because that's not going to work well. I have to do something about this, don't we? So how could I rewrite that? Yeah. So what I'm going to do is distribute this now. So V to the 1/3 times V to the negative 1 gets me V to the negative 2/3. Okay, it's not very pretty, but at least I can differentiate it. And this is quite interesting. What do you get if you multiply negative 5V e to the V with a V to the negative 1? What happens when that gets multiplied by that?
The V's go away.
Yeah. And so all you're left with is negative 5 e to the V. Okay, so algebra's finished. We've now written it down in a way that we can do the power rule. So multiply by the power and then reduce the power by 1. And my friend, the exponential function. If you differentiate negative 5 e to the V, you get -5 e to the v. Agreed? Right, now style point. I like that. I don't like that. Why don't I like that? Because it doesn't look like this. So we need to fix it. This is okay.
Wouldn't the coefficient for v be 1/3, not -2/3?
Oh, here,
Yeah.
let's check. This guy times this. So I'm starting with a
Got it.
-2. Yeah, it is -2/3, and then I take away 1, but it's worth checking.
Got
Yeah,
it.
this is okay. This fella needs to be fixed. Agreed. Now, if I put the negative on the top and do this guy, I can at least bring it down to the bottom. And then in the next line, know that everybody needs 2 lines. You could then do the 5/3, and that would be a cube root of v to the 5, take away 5 EV. And there we are finished. So looks, right? They kind of have the same shape to them, right? It's got radicals in it, and it's got e to the v's. It's got radicals in it. It's got e to the v's. Are we good? Right. Now, the one that I forgot is a very quick one. I'm going to warn you right now. Trick question. I'll take a volunteer. Differentiate that.
2x plus 2e to the x.
Is that everything?
I think so.
It is. Do you know what the trick question was? What mistake do some people make with things like e squared? Don't they think the derivative is e squared? Isn't e squared just a weird number? It's roughly 2.7128 times another 2.7128. And any number, no matter how weird it might look, is still a number. And all numbers get you 0 when you differentiate. That was it. So we're now moving on to the final phase. Here's my first example. Finding the equation of a tangent line at a given point. So you'll be given a function, you'll be given a point. We're going to find the equation of the tangent line. So the first thing you're going to do is you're going to find the derivative of this function. And it's not got anything really weird with it. Power rule is ready to be used. It's that guy. Now I need to find, so that's step 1. Step 2 is I need to find m, which is the slope of the tangent line. And I need to find it at x equals 2. And how do we get that? Well, the slope of the tangent line is the value of the derivative at 2. So that's going to be 6 lots of 2 squared. Take away 2 lots of 2. That's 24. That's 4. 24 take away 4 gets you 20. So I now know the slope of this tangent line, right? So this curve at that point, the slope of the tangent line is 20. And then I do the final step. I now get the equation of the tangent line. And this tangent line has a slope of
Your
20.
page is kind of going off the screen there.
Oh, there we go. So on the screen now?
Yeah, thank you.
So, right, so the equation of the tangent line has a slope of 20 at the point 2, 14. And to do that, you use this equation. Always this equation. It's called the point slope equation. This guy is called x1, and this guy is called y1. So what you've got is y take away this y coordinate, which is 14, is 20 the slope, x take away this coordinate, and I get 20x take away 40. If you add 14 to both sides, there is your equation of your tangent line. So it's really just an application of derivatives. Find a derivative, plug in 2 to get the slope of the tangent line, in this case 20. Use the point slope equation, and you've now got the equation of the tangent line. If I wanted to in a test, couldn't I put that into Desmos? Couldn't I put this line into Desmos? And if things were correct, wouldn't I see a really nice tangent line at whatever 2, 14 is? And if I did it wrong, wouldn't I see a line up here or some funny line going weird, but I wouldn't see a tangent line, and that would tell me I screwed up somewhere.
I can't see the page. Needs to go up a little. Needs to go up just a little.
Got it?
A little higher. And there-
But you can't see that? You're, is my screen weird?
No, is she on a phone?
Are you on the phone, Teresa?
No, I'm on my regular computer.
I'm
No,
just
I don't know
wondering why
what's
you
going on.
can't see the bottom half of my page. That would be really frustrating for you. I could try this. That's the maximum I can get out of my camera.
Is your Zoom window maximized, Teresa? Because if it's not maximized, it cuts off part of the video.
I don't know if that helps. That's weird. Okay, I'm going to keep going. Got,
Okay, I've adjusted things. Everything's
oh,
fine now.
thank God. Thank goodness. Phew. When I do my videos, they look okay when I produce them. Do you lose the bottom of the screens or anything? Just got me curious now that what I think you're saying, you might not all be saying it. When you look at videos, do they look pretty much like what we're saying right now, or do you lose bits? Okay, I get nods.
They
It
have
looks
to
like it's
answer.
good.
Yeah, I can't answer. I can't.
They seem fine to me, and I've watched them.
Right.
Me too.
Okay, just because if you went and told me right now, I'd have to go, oops, I'm going to have to figure out something to do with my video. Okay, let's keep going. I get 2 questions, and then I want to do the rest. The rest of the time I want to deal with our test. Okay, this is the same question. Find the equation of a tangent line. So in this particular question, there's not an awful lot that we need to do, but don't we have to rewrite it like a negative power so I can do the power rule? The derivative then is that guy, which becomes that guy. So in style points, that's the derivative. Now, the second part is we're now going to find the slope of the tangent line. Now, to get the slope of the tangent line, M, you find the derivative at, in this case, the x equals 4. So it's going to be 1 take away 4 times 4 squared. That's 1 take away a quarter, so that is 3/4. And then the point slope equation, and we're finished. So what do we know? We know that the slope is 3/4, and we know it passes through the point 4, 5. This is going to be called x1. This guy is going to be called y1. And the point slope equation looks like that. And what does that get us? Gets us y take away 4 is 3/4 x. Nobody noticed my mistake. I have just noticed my mistake. What did I do wrong?
It should be y minus 5.
Correct. And 4 goes there. And now we have 3/4 x take away 3, and that becomes 3/4 x add 2. If I had kept that mistake and switched to 5 and 4, I would get a line. It would be the wrong equation. If I was doing it in a test, and you can imagine the curve looked like this, my wrong line would look like that. The correct tangent line would look like that. Do you see? You can, and it doesn't take much. Can't you plug something into Desmos? That'll be your first equation. This will be your second. And they should match up perfectly if you've done it correctly. So there is one more thing that we haven't done, and that's called a normal line. So before I tackle this question, I'll show you visually what a normal line looks like. Imagine you had your typical polynomial, and we found this is the point that we're interested in here, P. And we found the tangent line, and it looks like that, right? That's what a tangent line is. Of course, if you continue a tangent line far enough, it will probably bump into something else. But that's meant to be my tangent line at P. There is another line that we sometimes want to get, and it's called the normal line, and it's this green line. And we're interested in finding the equation of this line. Now, what properties does a normal line have? It passes through P, just like the tangent line does, right? But it has one big difference. It's at right angles to the normal line. Okay. So it's the normal line is at right angles to the tangent line. Well, the tangent line is, they're perpendicular to both, right? Each one is perpendicular to the other guy. So how do we find the equation of a normal line? Well, what we really should be asking is, how do we find the slope of the normal line? Because if I know what its slope is, I already know the coordinates, and I can just use this guy again. Which means I'm going to have to tell you a little property that you may or may not know. So here it is. If two lines with slopes M1 and M2 are perpendicular, then M1 times M2 equals -1. So that is a property that links the slopes of two lines that are perpendicular to each other. So, for example, if I tell you that the tangent line has a slope of 3/4, then the normal line, which is perpendicular to this guy, we'll call it n, it's going to be -4/3. Why? Because if you multiply 3/4 with -4/3, don't you get -1? Now, the way I remember it is it's its negative reciprocal. Reciprocal. Turn me upside down and make me negative. So suppose this guy is 5. Won't this guy be -1/5? Suppose this guy is -7/10. What will the other guy be?
(10/7).
Negative reciprocals. Say it again, Ethan.
10/7.
Yeah. Do you see the connection between the two slopes? One's going this way, the other's going at right angles to it, perpendicular. If you're 7/9, I'm -9/7, right? Turn me upside down and make me negative. And that's how we are going to do our last question for today. And then we'll talk about this. Here is a curve, and we're going to find the equation of its tangent and its normal line. So first thing I'm going to do is differentiate it, because I don't need to fix anything. And I get 4x³ plus 9e to the x. That's good. Now I'm going to get the slope of the tangent line. And in this question, it's going to be at x = 0. So it's 4 lots of 0³ plus 9e to the 0. Well, that's nothing. But e to the 0 is 1, so you get 9. So far, so good. And now the tangent line. I know the slope is 9, and it passes through the point 0, 9. So the equation is y take away y1, m brackets x take away x1, y take away 9, 9 lots of x take away 0, y equals 9x add 9. That is the equation of the tangent. Now, I guess I'll call it number 4. This is going to be the normal line. I know it passes through 0, 0, 9. All I need to know is its slope. What's going to be the slope? The tangent line has a slope of 9. What's the normal line going to have a slope of?
1/9, -1/9.
There we go. So, y take away y1, I'm just going to call it m again. And what we have here is y take away 0 equals -1/9. And I just made a mistake, which I've just fixed. And we get y equals -1/9 x plus a 9. And that guy is the equation of the normal. So the equation of the tangent line and the normal line don't really require very much. You know, they're not that different. Don't you just need to find out what the slope is? So if you get the tangent line has a slope of 4, the normal line is going to be -1/4. If the tangent is 2/3, the normal is -3/2. It's the same equation, right? Same point. Pretty much everything else stays the same. Are we good with that, guy?
I'm not sure why it's called the normal. I was trying to figure that out. Like, why would that be normal in any way?
I could make up a made-up story, but that's all it would be. I don't know. I've never found out. I guess I've never found any great interest in one. Some things get names for ancient reasons that kind of, rational functions are just called rational functions because in the past fractions used to be called rationals. And then we changed the name into fractions for whatever reason, but the word rational stayed behind as a little historical leftover. So I wonder if normal had different meanings in some ways, but we've
Almost
lost
was
that
the
meaning.
name for a carpenter's square in like ancient Rome. So normal means at right angles too. It doesn't mean regular, it means at right angles, but we started using it to mean regular. But originally it meant something to measure a right angle. Yeah.
Hey, that's pretty cool. Thanks.
That is cool. How did you know that? Was that just something you read somewhere?
I have an English major. This is all I do with my time.
Yeah, but that's the kind of thing I like to hear. I like to learn things like that. I love things like that. So, see, it now makes sense. When you see a name that doesn't make sense, it probably at one time did. Right, so what I want to do for the time we've got left is, as I said, let's talk about the test as much as we can. I'm just frantically trying to open a particular page, which I now can't find, of course, but that's fine. I know it's around. Here it is. I'll move it over here. I'll move this one over here. I'm just getting it kind of ready for you. Open. That's good. I'm on student view. I am now. Okay. Let's see what works. Please work. Are you looking at 151 Canvas page? Right. You may have noticed that it has changed a little bit. The top thing you will now see is test 2 information. So pretty much it's the same as test 1 information the last time. There have been a couple of changes. Here's your first one. There's a guy here called what you need to know for test 2. So if anything I'm saying right now you forget, go here because it'll be written. A lot of it at least will be. So when I click on this, are you now looking at a PDF? Or will I have to go back in it? Right, I'll try and make it as big as I can. Yeah, that's as much as I can do. So let's, it's at 8, right? Now, if you can't make the 8 to 9 slot, we can arrange a 7 till 8 slot. We can arrange a 9 till 10 slot, or a 8:30 to 9:30 slot. We can arrange slots, right? So you have a class right after it and you don't want to be, turning up late, tell me about it, and we'll figure something out. It's going to start typically at 8. It's going to have 4 questions. It's going to cover limits at infinity. The kind of thing, the limit is x tends to infinity of x squared plus x over 2x plus 1, that kind of thing. Also vertical asymptotes. And the algebra techniques that you use to find out what those limits would be. Derivatives as rates of change. That's essentially the limit as h tends to 0 or the limit as x tends to a. Do you know that horrible long algebra way that you find slopes of tangent lines? It also includes the fact that a derivative of a position gets you velocity So you sometimes get questions that says, what's the instantaneous velocity of this ball at the 4-second mark? Do you know the questions where balls hit the ground and what's velocity do they hit the ground? All those kind of questions belong there. Derivatives of as a function are essentially draw pictures of what derivatives would look like. That's pretty much what those are. So you know the ones where we did polynomials and you did the horizontal tangent lines and this was plus and that was minus and we did some vertical asymptote stuff. That's what that question's going to look like. You can kind of tell there's going to be one question from each section, right? So I'm not giving much away by saying that. And then the last one is what we've just been doing. So you'll use the shortcut, right? Use the power rule, which is the only shortcut we have right now, and differentiate things. You might also be asked to find the equation of the tangent and or normal line as well. You feel comfortable, you know what's going to be in the test and what's not. Pretty much those are the main topics. Zoom lesson as always, here's the link. Not allowed to communicate with anybody living or dead, right? You're not allowed to do it by email, by Ouija board, by telegram, by any means of any kind. I think I'm being lawyer here. I have closed every loophole that I can think of. And if you found another way to communicate with a human being, it's also not allowed, right? So it's what you've got and that's it. You are allowed to use any notes that you've got, and you are allowed to use your calculator, and you are allowed to use Desmos. In fact, Desmos would probably be quite helpful for checking some of your work. For instance, today when I screwed up or almost screwed up one of the tangent lines, wouldn't Desmos have helped me find that out? So it's always worthwhile. The minute you do Desmos and it's a nice tangent line, it's a very good feeling because it makes you say, I got that one nailed, right? So it's a good feeling. You do have notes, but if you write a multitude of notes and you spend 20 minutes reading about how to do something, you'll never get the test done. So notes are helpful, but I don't need to know anything. If I just write it down, I can always look it up. It's not a very good strategy for doing this, any test. And all the other stuff, I'm going to show you. I wonder if I can close that. Yes, I can. Right. The rest of that stuff is here. I've gave you the Adobe scan method. Some of you have printers. That's fine. I'm trying to think what else there is. Some of you might have Cam Scanner or some other software. I don't really mind how it gets turned into a PDF as long as I get it. There's a video to help you. There's a video to help you. You click on this guy. There you go. Start assignment. Choose a file. Pick the guy. I would put it in my desktop. Hit open. Submit. As easy as that, right? So if you're using Adobe Scan, one way of doing it in Adobe Scan would be to send it to yourself as an email attachment, and then you can go to your computer, find your email, download it onto your desktop, and then you can upload it pretty much the way I just did there. I found that the easiest way, but you might have found a better way, and that's great. Moving on. If you click on that, there will be a test there. Obviously, it's not there right now. And fingers crossed Desmos is working. There you go. There's Desmos. What won't be there? And I close this? Yes, I do. All this stuff will disappear. So when you go into Canvas, all you'll see is test 2 information, and WebAssign will have disappeared. At least the homework will have. So you need to make sure that you've got good notes and easy to reference notes. Having 50 pieces of paper might be notes, but if you don't put them in some kind of organized way, you'll be spending forever trying to find the right one. Right, any questions? I think we are good to go then.